So in this question, we are given to consider the progression, which is given. If you're to consider this, you are given the terms that is 3, 1 over 2, 3, and so on and so on. If we are to go through this progression, we can see that there is a geometric progression of the constants from 3 to this 3 to another 3. We're going to have another 3, another term here, we have another 3, and so on and so on. So meaning to say we have a geometric progression which is of the constants. Then we also consider this part, 1 over 2, the 4 over 10, the 16 over 50. It's another progression that you're given. This one is not constant, it's different. So you have to study whatever that you're given. So already you're given, that's a geometric progression that we have. So we can also calculate the value of R4, this other part of 1 over 2, the 4 over 10, and so on. So if we are to divide, that's 4 over 10, remember, we're going to consider second term over the first one. So that's 4 over 10 divided to 1 over 2. This was going to give us 4 over 5. We do the same thing, the 16 over 50. If we had to divide 16 over 50 divided by 4 over 10, it was going to give us the same 4 over 5, which is different from this one of 3 to 3 and so on. This part is going to be 1 because it is a constant. If you divide 3 divided by 3, that's a 1. 3 divided by 3, that's a 1. All right, here we are just studying, guys, what is happening. Let us go to the question. We are given on 3.11 to write down the next two terms of the progression. So understanding this part, it was going to be easier for us to obtain the two terms because we are starting with a constant, then we move on to another progression, constant, and so on. So meaning to say the term that was going to follow here was going to be a constant, which is 3. So what we need is to determine the one that is following after 3. So we already have a 3. What about the one that is following after a 3? From the common ratio that we have of 4 over 5. What is the relationship between these terms from 4 over 5? All right, I want you to take note here. It's very true that if you divide these two terms, you are going to obtain the 4 over 5. But I want you to notice something in terms of these numbers, all right? Let us take our calculator so that we notice this part that I want to explain. It is best if we are using the calculator so that we understand each other on this part. All right. So if we are to consider this part here, we have got, or we are given 1 over 2. We are considering this part. It's 1 over 2. Then we've got a ratio of 4 over 10. So I want you to see what was going to happen there. 1 over 2. We know that to obtain the following term, you're supposed to multiply by the ratio, which is 4 over 5. Multiplying by 4 over 5 like this was going to give us 2 over 5. Take note, it was going to give us 2 over 5. But guys, this is what we had before. This is 4 over 10. I want you to see what is happening here. 4 over 10. Exactly what we had before when you divided 4 over a 10 like this. Okay? Then divided to what? To 1 over 2. This is how you obtain the common ratio. Remember here, you divided to 1 over 2 like this. All right? That's 1 over 2. All right. Need to remove 1 here. I don't know what's happening here. Okay. Let's hope it's not going to affect us. So that is 4 over 5, as you can see here. Exactly this 4 over 5 that we are seeing here. So are we wrong in our calculation here when we are to say, if I am to multiply 1 over 2 times the ratio, because I'm supposed to have exactly the next term if I multiply by this ratio. But this is not what I'm obtaining. I'm obtaining 2 over 5. What happened? If you are to check, the following term is 2 over 5. This one, 4 over 10. Okay, let's reduce this one on our calculator. 4 over a 10. 4 divided by 10 like this. That's 2 over 5. So we can see that on each answer that we are obtaining, it is not exactly what we are having here. instead of them writing 2 over 5, they are writing 4 over 10. Instead of them to write this one, 2 over 5, they are writing 4 over 10. So what exactly are they doing? They simply multiplied by 2. The answer that we have, which is the 2 over 5, they simply multiplied it by what? By 2. So in this case, it is because of a calculator. The calculator will keep on reducing that part. So we have to multiply by 2 each and every number that you have. But on a calculator, even if you multiply by 2 over 2, it will keep on giving you the simplest value. So this part, it is you is supposed to change. It was 2 over 5 like this. So what they simply did was to multiply by 2 over 2. 2 times 2, which is 4. 5 times 2, which is a 10. That's this 4 over 10. It is the same. If you are given 4 over 10, guys, you can reduce this one by dividing by what? Dividing by 2. You obtain this one. So here they just want to trick you. You're supposed to be very careful. So meaning to say, for the next term, because we're supposed to multiply to say 16 over 50 times what? 4 over 5 to obtain the term that is following here. So on your calculator, there you're supposed to be careful because this was going to happen. You're going to have 16 over 50 like this. Multiply by 4 over 5. So you're going to multiply by 4 over 5 like this. On your calculator, you're going to obtain 32 over 125. This is what you're going to obtain on your calculator. 32 over 125. This is what you're obtaining here. But if you are to write it this way, it is wrong because according to this progression, we saw that instead of being given, all right, this is, all right, sorry, this is 4 over 10 here. Why am I writing 4 over 5? Instead of us having 2 over 5, they are giving us as 4 over 10. So also you're supposed to make an adjustment here because you are given this. The same way you have to multiply by 2 over 2, meaning to say we are supposed to multiply by 2 over 2. That is 32 times 2, which is 64. 125 times 2, which was going to give us 250. So this is the exact number that you're supposed to have here, which is 64 over what? Over 250. If you are to use the 32 over 125 according to this progression, it means it is wrong. Guys, you see, when you are given a sequence or a certain formula that you are given, you are supposed to follow up the way it is given. This one, it is not about my answer is supposed to be in simplest form. So the answer in simplest form is supposed to be 32 over 125. No. If it was like that, they were going to reduce these numbers. 4 over 10. Can it not be reduced? It can be reduced, but they had to write it as 4 over 10. There is a meaning on that. 16 over 50, it's not in simplest form. We're supposed to write this one in simplest form. But instead, they're giving us something like this. They want you to follow that. So you have to be careful when answering your questions, all right? So this one was supposed to be a direct question, but just for us to understand. All right, let's move on to 3.12. We are being asked to calculate the sum of the first 35 terms of the progression. Another tricky part of the question. What type of a progression is this one? Because if we actually have something which is the same, a normal geometric progression, let's say it was just something that we are used to, 1 over 2, 4 over 10, 16 over 50, the way that maybe we are given something like this. Guys, we can simplify the sum because it is something that is the same throughout. But in this case, there are two sequences that we are given here. One of the constants and the other one that is having a common ratio of what? 4 over 5. So you have to be careful. There are two of them. So how many terms now are we going to have for the constants? How many terms are we going to have? Because here we are just given a total of them, 35 terms. Out of the 35 terms, how many are the constants? That is the question. So for the constants, Let's start with the constants. So if you are to check here, the constants is the one that we are starting with the constant here. So it's like we are given terms. Let's say, I'm going to put it this way. I hope you understand me here. I hope you are going to understand me here. Let's say we are given, I want you to see this part. I'm going to use 5 numbers. 1, 2, 3, 4, 5. These numbers, they're different. That's why I'm using different colors. This is our first term, which represents the constants. These ones in blue, they represent the constants. So I want you to see something clear using few numbers, like we are working with 5 numbers. If we are dealing with 5 numbers like this, starting with the constant, starting with this blue one, this one, how many terms are we having? Out of 5, how many do we have which are blue? We have got 1, 2, 3. There are 3. Out of 5, there are 3. So take note there. There are 3 out of 5. And these other ones that are remaining, there are 2. So meaning to say, in terms of numbers, these terms, they are not going to correspond. Out of 35 terms, they are not going to correspond to say, these ones, they are 20. The other one is 20. Let's say half. It cannot be like that. It was supposed to be 5 over 2 divide, which was going to be 2,5. But because the first one, the one that is starting, it is going to be more in these terms that you are given, out of 5 terms. So you're going to take the third one. So understanding this, guys, to say the first term is going to carry more terms, it was going to help us in this manner to say there are 35 terms. So simply divide by what? By 2. All right. So if you have to divide 35 divided by 2, that's 17,5. Meaning to say we need the next term, which is the next whole number, which is 18. The next whole number, just like what we had, 2,5. But we saw that the numbers were what? Were 3. We just used the next whole number. So in this case, out of 35 terms, 18 are the constants. Because we are starting with the constants, so they are the ones which are many. Remember, 35 minus 18 gives us what? A 17. So the 17 is the one for these other terms that are following that the constant, that the common ratio that we are given of 4 over 5. But the first ones, they're 18. So when we are given this, we have to be careful. Because this number is not an even number where you divide by 2, then you say these ones, they will be 18, the other ones, they will be 18. It's not an even number. So these constants, since we are starting with the constants, if our sequence was starting with this one, let's say it was like this, starting with 1 over 2, followed by 4 over 10 like that, it means those ones with a common ratio of 4 over 5, they are the ones which were going to be 18. Then the constants, because they are the ones that are following, they are the ones which were going to be what? Which were going to be 17. That is the case there. The first one is the one that carries the bigger value. The one that follows carries a smaller value because these numbers are not evenly distributed. So for constants, we say they are going to be what? 18. So for constants, the number of terms, they're 18. All of them, they're 18. Then for the other geometric that we are given, for the other, all right, I'm just going to write in short, for the other geometric, n is equal to 17, meaning to say we have got 17 terms. All right, so if it is like that, we are going to determine the sum differently. We determine the sum for the constants. We determine the sum for that other geometric progression that we are given. So how can you calculate the sum of the constants? The constants, guys, is just like we're given 3, 3, 3, 3 like that. 18 of them. You are adding 3 plus 3 plus 3, 18 times. So it is simply, all right, so this one is going to be such that, so the sum for these 18 terms is simply 3 times 18. you are adding 3 plus 3 plus 3 plus 3, 18 times. So it is simply 3 times 18. All right. So that was the sum. So 3 times 18 was going to be 54. All right. Or you can use any other understanding that you understand, guys, to add. You can use any concept that you understand. But guys, you are adding 3 plus is the same number 18 times. So it's 3 times that number of times. All right. This is for the constants. Moving on to the other, which is for the geometric. All right. So for the geometric sequence that we are given, we saw that there are 17 terms that are remaining. So we are going to determine the sum of the 17 terms. How do you determine the sum? All right. Having this, we saw that our ratio is 4/5. All right. Remember, I talked about this, guys, when dealing with a geometric series, determining the sum. We've got two formulas that we can use. All right. Two formulas that we can use for Sn. We've got this formula where Sn is equal to a r to the exponent of n minus 1 over r minus 1, which is the one that you're given in your formula sheet. This one, yes, you can use this one any, guys. It is used when r is greater than 1. Then we also have Sn is equal to a into 1 minus r to the exponent of n over 1 minus r. This one is used when r is less than 1. So as you can see there, we are dealing with a decimal. R is a decimal. 4/5 is a 4/5 is a decimal. If you convert this is 0.8. It's less than 1. So the best formula to use was going to be this one. Guys, I'm not saying to use this formula is wrong. No, you can use this formula. You still obtain the same answer. So I want you to use this one and prove if truly we are going to obtain the same answer. All right. So in this case, I'm going to use this one. So that is the sum. All right. Let me just write as Sn. I'm just going to remove this one. So remember, I said I'm going to use this one. So I'm going to take this as Sn. This is for the geometric, remember? So we saw that it's a into 1 minus r to the exponent of n over 1 minus r. Let us substitute our values. It's for how many terms? 17 terms. The one that are forming the geometric that is remaining, they are 17. So a being the first term of that, of these terms, which are not constants. So we are starting with this one. This is our first term, second term, and so on. We are considering the other terms, this one, not the constants. So our first term there, which is a, is 1/2. So that was going to be 1/2 into 1 minus r there, which is the ratio that we have between these terms, which is 4/5. So that's 4/5 to the exponent of 17. Remember, n, there are 17 terms that we are going to remain with. Everything over 1 minus r. Remember, our ratio there is 4/what? 4/5. So that is it. You were simply going to use your calculator to determine the sum. So make sure you use your calculator, guys, properly. All right, let us have our calculator here. So this is it. We have got 1/2, this and that. We're just going to have a fraction. Let's just hope this calculator is not going to affect us. So that's 1/2. Put a fraction, 1/2 like this. Move aside, open the bracket. That's 1 minus the 4/5. You can just open a bracket if you want. 4/5 like this to the exponent of 17. Then close the bracket. Just move this aside, then close the bracket. Over what? 1 minus 4/5, just like that. 1 minus 4/5. So this was going to give us 2,4, and so on. So you can even fix this to 2 decimal places. So shift, go to the setup, fix on number 6. So to 2 decimal places, press 2. That's 2,44. So that is 2 comma 4 like this to 2 decimal places. So this is the sum of the 17 terms for that geometric progression that we are given, which has got a common ratio of 4/5. But we saw that there was a sum before, there was a sum here for the constants. We calculated this one for the what? For the constants. The 18 constants add up to 54. So what is the sum of all the terms? That is the sum of the what? First 35 terms. You add the two. 18 plus 17, remember, is 35. So therefore, the sum of the first 35 terms was going to be, you add, so it's simply S18 plus S17. All right. These ones, we saw that they add up to 54. All right. So these ones, they add up to 54. These ones, they add up to 2,4, 4 like this. So let us add these two. We were going to obtain 56,4, 4 like this. So this is the sum of the first 35 terms. So these typical questions, you see, examination, guys, they are testing you. It's exam. They want you to understand everything that you have learned, all the basics. So this was corresponding to the 5 marks that we are seeing there. All right. So let's see another question. We just hope with the time, we are going to do as many questions as we can so that you prepare yourselves as you are preparing for the exams which are ahead of time. Considering the other question, which had 4 marks. All right, 4 marks. What is it about this question? Calculate, we are given a summation. Remember the sigma notation. That is the summation. I said this simply represents sum of. So they are saying calculate the sum of these terms. But on top, we can see that these terms, they do not end. There is infinity there. Once you see this infinity there, they are simply saying calculate the sum to infinity, meaning to say we are dealing with a geometric series, and the sum to infinity is given as we have from our formula sheet. The sum to infinity is given as a over what? 1 minus r. So that was the case of our question. Just like that. So that is what we're going to have. So this is given as a over 1 minus r. So what we need is a, the first term, then r, the common ratio. So a is the first term, which corresponds to T1. When n is equal to 3, that is our starting point. When n is equal to 3, that's our starting point. So we're going to substitute 5 into 3 to the exponent of 1 minus n, the corresponding first value. We are starting at what? At 3. So that was going to give us T1, which is 5 over 9. So we have our A. All right. In order for us to have R, we need to determine the second term, then divide. All right. So T2 is the second term. Remember, you're moving 3. We move on to 4, to 5, to 6, to 7, and so on and so on. So we can use 4 this time following. After 3, we're going to move on to 4. So that's 3 to the exponent of 1 minus 4, which was going to give us 5 over 27. So these two can give us the common ratio because we understand that's T2 over what? Over T1. Guys, sum to infinity is under a geometric progression. We talk of the common ratio there. So dividing these two terms, what we're going to have 5 over 27 divided to 5 over 9. That's T2 divided to T1. That was going to give us 1 over 3. We have the ratio there. So meaning to say with this, we can determine the sum to infinity. All right. So the sum to infinity was going to be given as A. Remember, that's our T1, which is 5 over 9. So we've got 5 over 9 over 1 minus r, which is our common ratio. That's 1 over 3. So that is it. So the sum to infinite in this case was going to give us 5 over 6, right? So take note, this one is just a single number when using your calculator. So these are some of the typical questions. We just need to work out as many questions as we can. Prepare yourselves for the exams which are ahead of time.